Question number 6 says, Farmer Brown makes troughs to feed his animals using wood that is 5 centimeters thick. As shown in the diagram below, the troughs are rectangular based, open at the top, and have external dimensions of 300 centimeters by 190 centimeters by 160 centimeters. By calculation, shows that the internal capacity of the trough is 9,091,000 centimeters cubed. All right, first of all, it's a cube, so the capacity, which is the internal volume, would be equal to AH. So A is the area of the cross section, which is a rectangle, so it's length times width times height. Now, since it's the internal dimensions, the length would be 290. So remember, the external length is 300. If you take out 5 centimeters from both sides, it's 5 plus 5 is 10, 10 from 300 is multiplied by the width. The width is 180, internal width is 180. Why? Because the external is 90, the external width is 190. And remember, the wood is 5 centimeters thick. So if you take off 5 centimeters from both sides, 5 centimeters here and 5 centimeters here, the internal width would be 180 times the internal height, which is, let us assuming it is, because the base is 5 centimeters, would be 155 centimeters. So that's the internal length multiplied by width multiplied by height, because the internal of the container is a cuboid, and the internal length is 300 minus 10. The internal width is 190 minus 10, and the internal height is 160 minus 5, which is 155. So let's multiply this, and if we're correct, we should end up with 8,091,000. So 290 times 180 times 155, and we are correct, 8,091,000, and this is centimeters cubed. All right, so next we're asked to calculate the volume of wood needed to make the trough. Well, to determine the volume of wood that you need, you simply need to subtract the internal volume from the volume of the entire cube. So volume of wood needed would be the external volume, which is 300 times 190 times 160 minus the internal volume, which is 8,091,000 centimeters cubed. So this is 300 times 190 times 160. This is 9,120,000 minus 8,091,000. So minus 8,091,000. The answer is 1,000,000 29,000 centimeters cube is the volume of wood needed to make the trough. All right, C says, Farmer Brown must paint the internal surface of the trough, given that 1 gallon of paint covers approximately 280,000 centimeters square of surface. We're to calculate the amount of paint in liters that is needed to paint the internal surface. All right, first of all, let's determine the internal surface. So the internal surface area. The internal surface area, well, if we use a formula, it would be equal to pH plus A. There's only one N as an internal surface. There's no top. pH would be the perimeter of the internal, which would be the internal perimeter, which would be 290 plus 290, that's two sides of length 290 plus 180 plus, 180 plus 180 times the internal height, which is 155, plus the area of the base, which is 290 times 180. All right. So pH gives you the area of the four sides and the four internal sides, and 29 times 180 gives me the area of the base. So let's find out what P is. So it's 290 plus 290 plus 180 plus 180. That's 940 times 155 plus 29 times 180. This is 5,200. 220. So let's just get a final answer. 940 times 155 plus 5,220. This is 152, comma 470 centimeters square. That is the internal surface area of the trough. Well, obviously, I think one gallon of paint can paint it, because 1 gallon of paint. All right, so let's find out number of gallons needed, or fraction of gallon needed. Fraction of gallon needed. So the fraction of 1 gallon that is needed would be 152,470 over 28,000. All right, let's see what that works out to be. $280,000. All right, so we'll simply multiply this by the 3.0 3.79 liters. So multiply that by 3.79 liters, which is 1 gallon. And this is saying 2.0. And they want the answer to how? They can tell us how they want the answer. So let's give our answer to 3 significant figure. According to this, our answer is 2.06 liters is needed to paint the internal surface of 1 trough.